Determine the empirical formula of a compound containing 29.09% sodium, 40.55% sulfur, and 30.36% oxygen. There are 6 steps to solve this problem. Step 1 is to assume that the mass of the sample is 100 grams and determine the mass of each element in moles. Step 2 is to determine the lowest mole amount. Step 3, for each element, divide the mole amount by the lowest mole amount and round the value. Step 4 is to determine the least common multiple. Step 5, for each element, multiply the value of the element in step 3 by the least common multiple in step 4. And step 6 is using values in step 5 as subscripts for each corresponding element, write the empirical formula of the compound. Now step 1. Assume that the mass of the sample is 100 grams. Determine the mass of each element in moles. Now the formula to determine the mass of an element in moles is the mass percentage of the element divided by the molar mass of the element. So the mass of sodium in moles is the mass percentage of sodium, which we can obtain from the question, and the mass percentage of sodium is 29.09%, divided by the molar mass of sodium, which we can obtain from the periodic table. And the molar mass of sodium is 22.99. So the mass of sodium in moles equals 29.09 divided by 22.99 equals 1.265. Mass of sulfur in moles equals mass percentage of sulfur, which we can obtain from the question, and it is 40.55%, divided by the molar mass of sulfur, which we can obtain from the periodic table, and the molar mass of sulfur is 32.06. So the mass of sulfur in moles equals 40.55 divided by 32.06 equals 1.265 moles. Mass of oxygen in moles equals mass percentage of oxygen, which we can obtain from the question, and the mass percentage of oxygen is 30.36, divided by the molar mass of oxygen, which we can obtain from the periodic table, and the molar mass of oxygen is 16.00. So the mass of oxygen in moles equals 30.36 divided by 16.00 equals 1.898 moles. Now step 2. Determine the lowest mole amount. We can determine the lowest mole amount by looking at the mole amounts in step 1. The mole amounts are 1.265, 1.265, and 1.898. So the lowest mole amount is 1.265. So the lowest mole amount is 1.265. Now step 3. For each element, divide the mole amount by the lowest mole amount and round the value. We have the mole amounts calculated in step 1. So the mole amount for sodium is 1.265, the mole amount for sulfur is 1.265, and the mole amount for oxygen is 1.898. So for sodium we need to divide 1.265 by the lowest mole amount, which is 1.265, and the value is 1.00. For sulfur we need to divide the mole amount, which is 1.265, by the lowest mole amount, which is 1.265, so the value is 1.00. For oxygen we need to divide the mole amount, which is 1.898, by 1.265, which is the lowest mole amount, and the value is 1.5004. We need to round this value, and the value becomes 1 1.5. Step 4 is to determine the least common multiple. The least common multiple to make all the numbers whole numbers is 2, because 2 is the least number that you can multiply each number by to make all the numbers whole numbers. Now, if we multiply 1 by 2, we have 2. If we multiply 1 by 2, we have 2. Now for oxygen, 1.5 is not a whole number. If we multiply 1.5 by 2, we have 3, which is a whole number. So the least common multiple is 2. Step 5. For each element, multiply the value of element in step 3 by the least common multiple in step 4. Now let us look at step 3. The value of sodium is 1, the value of sulfur is 1, and the value of oxygen is 1.5. So for sodium, we need to multiply 1 by the least common multiple 2, and the value is 2. For sulfur, we need to multiply 1 by the least common multiple 2, and the value is 2. And for oxygen, we need to multiply 1.5 by the least common multiple, which is 2, and the value is 3. Step 6. Using values in step 5 as subscripts for each corresponding element, write the empirical formula of the compound. So the empirical formula of the compound: for sodium, the subscript will be 2. For sulfur, the subscript will be 2. And for oxygen, the subscript will be 3. So the empirical formula of the compound is Na2S2O3.